In 1859, the oil industry began in the quiet farm country of Pennsylvania. Extracting oil meant punching a hole 50 feet into the earth and building a simple wooden derrick to collect what naturally flowed to the surface. These early onshore reservoirs were so plentiful and the oil so easy to reach that drillers quickly flooded the market. By 1861, individual wells produced thousands of barrels a day, and crude prices plummeted to 10 cents a barrel. Today, that easily accessible shallow oil is largely exhausted. To meet global demand, engineers build massive offshore concrete megastructures to reach reservoirs buried thousands of meters beneath the seafloor. At these extreme depths, the Earth yields a hot, turbulent mixture of crude oil, fossil water, natural gas, and abrasive sand. Modern energy production requires a massive reverse assembly line designed to physically tame and purify this violent geological cocktail. The first mechanical step in this purification process requires holding back the immense natural pressure of the underground formation. Engineers install a wellhead directly over the wellbore to cap it. This heavy-duty steel structure utilizes a strict hierarchy of valves, like the master and swab valves, to seal the well and prevent high-pressure blowouts. The most critical regulating component here is the choke valve. Down in the reservoir, fluid can hit the surface at up to 14,000 psi. The choke safely restricts that massive earth pressure, stepping it down to a manageable flow rate for the facility. Once regulated, the individual streams from dozens of these distinct wellheads are collected and combined into a massive piping network known as a production manifold. You cannot separate a fluid that is tearing through steel pipes at explosive speeds. Successfully taming that initial well pressure is the strict physical prerequisite for the entire operation. The gathered fluid is fed into the gas oil separation plant, or GOSP. This horizontal gravity separator is the primary processing hub where the chaotic fluid is finally split into commercial fractions. This diagram shows the interior of a production separator. Inside, physics takes over. Given a retention time of about 5 minutes, the fluid naturally stratifies. Lighter gas bubbles to the top, heavy water sinks to the bottom, and crude oil floats in the middle. Internal mechanical components assist this natural process. A demister, for example, forces the escaping gas through a specialized mesh, catching tiny liquid droplets and preventing the fluid layers from mixing back together. This separation cannot happen in a single step. The pressure must be reduced gradually across a staged series of high and low pressure separator vessels. A sudden massive pressure drop triggers flash vaporization. This is a highly dangerous condition where volatile liquid hydrocarbons instantly boil into rapidly expanding gas, creating severe instability. Stepping the pressure down slowly controls the release. By meticulously balancing pressure drops and gravity, the plant yields clean, stabilized oil and gas from raw geology. But isolating the natural gas creates an immediate physical problem. It has lost its pressure. It no longer possesses the kinetic energy required to push itself through an export pipeline to the shore. To move the product, the gas is routed into massive, turbine-driven centrifugal compressors. These machines act like giant fans, tightly packing the gas molecules back together and driving up the pressure. Compressors require a specific minimum volume of gas to operate safely. If the flow drops too low, an anti-surge valve automatically opens, recirculating gas back to the inlet, so the compressor doesn't violently tear itself apart from aerodynamic instability. This heavy mechanical compression acts as an artificial heartbeat, providing the shear force needed to push the isolated gas off the production facility and out into the global transport network. Before any product leaves the platform, it crosses one final threshold, the fiscal metering station. This schematic details a fiscal metering system, the exact moment of custody transfer. Fluid is split across parallel meter runs to ensure absolute accuracy. Below, an automated prover loop constantly calibrates these meters, since even a fractional 0.3% error translates to massive revenue loss. Once measured, the hydrocarbons enter major export pipelines. To ensure safe operation, companies deploy intelligent pigs, sophisticated robotic devices that rocket through the pipes to inspect the steel walls for corrosion and defects. While natural gas might travel through miles of subsea pipe or be supercooled into a liquid state and loaded onto massive LNG ships, the objective is exactly the same: delivering the refined energy to global markets. Whether operating a 19th-century wooden derrick or a modern, deep-water floating city, the oil and gas industry succeeds through the relentless, step-by-step mastery of extreme physics to keep the modern world turning.